Hello and welcome back to the gRPC course. In the first part of the lecture, we have learned how to implement unary RPC in Go. In this second part, we will learn how to do that in Java. The plan is the same. We will review how to define a service with protocol buffer, implement a server, the client with unit test, and handle errors, status codes, and deadline. Okay, let's dive in. I will open the IntelliJ IDEA project, then open the terminal to copy the laptop service.proto file that we have written in the first part to our Java project at the source main proto folder. Alright, the file is here. I will review its structure a bit for those who haven't watched the lecture with Go. First, we have the create laptop request message with a simple laptop field. Then we have the create laptop response message with a string field, the laptop ID. Then we define the laptop service with a service keyword. Inside that service, we define our unary RPC with the RPC keyword. The name of the RPC is create laptop. It takes a create laptop request as input and returns a create laptop response. Very simple. Now let's build the project to generate Java code from it. It throws an error, javax.annotation.generated. To fix this, we open the browser and search for Maven javax annotation. Open this javax annotation API page. Choose the latest version 1.3.2. Copy this Gradle setting and paste it in the dependencies block of our build.gradle file. Wait a bit for the Gradle to configure it. Then click Build again. This time the build is successful. Let's look at build generated source proto main gRPC. The laptop service gRPC class is generated here. Let's see what we have inside. First, we have the laptop service stub. This is an async stub that supports all call types for the service. Then we have another blocking stub that supports unary and streaming output calls. We will use this blocking stub in this video. We also have a listenable future style stub. You can use it if you want to use future. Next is an abstract class, laptop service implement base. We will have to implement the create laptop function of this class on the server side. There are several more things at the bottom of the file, but we don't have to care about them for now. So let's close this file and start coding. I will create a new service package. On the server side, we create a new laptop service class. We will have to write some logs, so let's declare a logger here. The laptop service class must extend the laptop service implement base class. We have to override the create laptop function of that class. First, we get the input laptop object from the request. We get the ID of the laptop and write a simple log saying that we've got a create laptop request with this ID. Now we check if the laptop ID is empty. Then we have to generate a random UUID for it. Else, we will check if the provided ID is a valid UUID or not. If the UUID.fromString function throws an illegal argument exception, then it is an invalid UUID. So we do a try cat here. If we catch an error, then we will return it to the client. Simply use the response observer.onError function here to return the invalid argument status together with a description message and convert it into a runtime exception. Then return right away. Otherwise, if everything goes well, we have a valid laptop ID at this step. We can safely set this ID to the laptop object like this. Here we have to convert the laptop into a builder, so that we can use the setter function to set the ID. Okay, normally after this, we have to save the laptop to the database. However, I don't want you to be distracted, since this is a course about gRPC, not about database. So I will just use an in-memory storage. Let's create a new file, laptop store. It should be an interface so that we can easily implement different kinds of store whenever we want. This interface will have a save function to save a laptop to the store. Keep in mind that for the simplicity of this lecture, I use a protobuf laptop object directly as a data store model. But you should consider using a separate object model here to decouple between the data transfer and data storage layers. Alright, we also need a find function to search for a laptop by its ID. Now let's create a new file to implement the in-memory laptop store. We will use a concurrent map to store the laptops. The key is a laptop ID string, and the value is the laptop itself. In this constructor, we create a new concurrent hash map with initial capacity of 0. In the save function, we check if the laptop ID is already in the store or not. If it is, we throw a new already exists exception. Let's define that exception in a separate file. It will extend the runtime exception class and call super constructor with the input message. Okay, now in the save laptop function, we will do a deep copy of the laptop and save it to the hash map. In the find function, if the map doesn't contain the laptop ID, we just return null. Otherwise, we deep copy the object from the map and return it. Alright, let's go back to the laptop service. We declare a laptop store object and initialize it from this constructor. Now in the createLaptop function, we can call store.save to save the laptop to the store. If we catch an already exist exception, we will return the already exist status to the client. Else, if we catch an unexpected exception, we will return the internal status, which means internal server error. If there's no exception, we will create a new response object with a laptop ID and return it to the client by using responseObserver.onNext function. Finally, we call onCompleted function to tell client that the RPC is now completed and no more output will be sent. We will write a simple log here saying that the laptop with this ID is successfully saved to the store. And that's it for the laptop service implementation. Now let's create the laptop server class to listen to gRPC requests and call laptop service to serve the request. Similar as before, we first create a new logger to write some logs. Then we will write two constructors. The first one takes a port and a laptop store as input. And the second one will take one additional input, which is the gRPC server builder. This constructor will be useful when we write the unit test later. In the first constructor, we create a new server builder for the input port, then call the second constructor with it. We will define two private fields in the laptop server class, one for the port and the other for the gRPC server. In the second constructor, we save the input port to the class. We create a laptop service with the input store. Add the laptop service to the server builder and call the build function to make a gRPC server. Next, we write the start function to start the server. we write a log here saying that the server is started on this port. Then we need a stop function to shut down the server. We use the await termination function here to wait until the server is completely terminated. At some time, the JVM might be terminated externally due to some interrupt or unexpected errors. We should add a shutdown hook to the start function so that the gRPC server can be gracefully shut down. In this hook, we just write a log to the system error and call the stop function of the laptop server object. Next, we write one more function to block the main thread until the server shuts down, because the gRPC server uses daemon threads. Alright, now we can write the main function. First, we create a new in-memory laptop store. Then we create a new laptop server on port 8080 with that store. We call server.start to start the server. And finally call server.block until shutdown. Now the server is ready. Let's click this button to run it. As you can see, the server is started on port 8080. Now I will use the Golang client that we have written in the previous video to connect to this server. I will run make client in the terminal to start the client. Yay, the laptop is created with this ID. On the server side, we also see a log saying that it has received a create laptop request with the empty ID, and another log saying that the laptop is saved to the store. However, we also see a transport failed message after that. It's not an error, since the log is at info level. When I search for this on the web, it looks like this is a new bug of the gRPC Java library, when the client closes the connection too fast, and the RPC call is not fully completed. Although the response has successfully been delivered, the server still logs this message at the info level, while it should be at the find level. The pull request to fix this has been merged recently, so I hope it will be okay in the next release. For now, there's a quick fix. After receiving the response from the server, we can just sleep a bit, let's say 1 second. Then when we run make client again, we won't see the failed message anymore. Next, let's try the case when the ID is already generated on client side. It worked. As we can see on the server logs, the laptop is created successfully with the ID that client sent in the request. Now let's try the case where the laptop ID already exists. Cool, it says the laptop already exists, exactly as we expected. How about the invalid case? The invalid argument error code is returned. Great. Now let's learn how to write the client in Java. I will create a new laptop client class in the service package. As usual, we create a new logger. Then the constructor will have two arguments, the server host and port. To connect to the server, we need a managed channel object. It's like a connection between the client and the server. We also need a blocking stub in order to call the unary RPC. In the laptop client constructor, we use a managed channel builder to build the channel with a specified server host and port. For simplicity, we don't use a secure connection yet, so let's just use plain text for now. After building the channel, we can use it to create a new blocking stub. Now we write a shutdown function to gracefully shut down the channel. We will wait for the channel to terminate for at most 5 seconds. Next, we will write create laptop function to call the RPC on the server to create a new laptop. First, we build a new createLaptop request with the input laptop object. We make a default createLaptop response instance. Then call blockstub.createLaptop and pass in the request. If we catch an exception, we write a severe log message and return. If the call is successful, a response will be returned. We write an info log saying the laptop is created with this ID. Alright, now type psvm to create the main function. First, create a new laptop client that connects to localhost at port 8080. Make a new laptop generator and generate a random laptop. By the way, in the lecture 9, I forgot to set a random ID for the laptop object, so let's call setID function here to set its value to a random UUID string. Back to our main function. Now we can call client.createLaptop with a random laptop object, surround it with a try block, and finally call client.shutdown to terminate it cleanly. Okay, now let's run the server implemented in Go and connect this Java client to it. The laptop is successfully created. Let's try the case where the client sends an empty laptop ID. A laptop is still created. On the server side, there are two logs, one log with empty ID and the other with a random UUID. That's exactly what we want. Now, if we try to send an ID that already exists, the server will return an error with already exist status. However, it's still showing as a severe log, while we only want this to be a normal info log. So let's update the code a little bit. Here, if we catch a status runtime exception, we can call e.getStatus.getCode to get the status code of the response. If it is already exists, then it's not a big deal. We just write a simple info log here and return. Else, we write a severe log, just like other exceptions. Now the log is an info, laptop ID already exists. If we change the ID to invalid and rerun the client, there will be a severe log with an invalid argument status code. So the Java client is working very well with the Go server. Now let's try it one more time with the Java server. The server is started on port 8080. Now let's run the client with empty ID. The laptop is created. Now the existed ID case. The laptop ID already exists. Then the invalid ID case. Request failed, invalid argument. And finally the case with the valid ID. The laptop is created. Alright, so the Java client is also working perfectly with the Java server. Now I will show you how to handle request timeout. Let's say on the server we do some heavy processing before saving the laptop to the store. I will use a simple sleep for 6 seconds here. Then on the client side, we set the deadline of the request to be 5 seconds. Now run the server and run the client. After 5 seconds, we get deadline exceeded error. However, on the server side, the laptop is still getting created. Let's go back to the server to fix this. After the heavy processing, we will check the current context status. If it is cancelled, we write a simple info log here. Call responseobserver.onError with status cancelled and return immediately. Now, if we restart the server and rerun the client. This time there is a log on the server saying request is cancelled, and the laptop is not saved to the store anymore. Perfect! Now before I show you how to write unit tests for this unary RPC, I will comment out this heavy processing block. Okay, on this laptop server class, we press Option Enter and select Create Test. Choose the Setup and Tear Down checkbox and click OK. The test file will be generated in the test Java folder under the correct package. In the setup function, we will generate a server name and create a new in-process server builder with that name as a direct executor. Next, we declare 3 private objects: a laptop store, a laptop server, and a managed channel. In the setup function, we initialize the store as an in-memory laptop store. We create the server with the server builder, port 0, and the laptop store, called server.start. And finally, we create the channel as an in-process channel for the generated server name, also as a direct executor. We also want to clean up the connection after the test, so we will add a gRPC cleanup rule here and register the channel with it. In the teardown function, all we have to do is to call server.stop. Okay, now let's write the first test. It will test the create laptop RPC with a valid laptop ID. First, we create a new laptop generator and generate a random laptop object. Then we build a create laptop request with the generated laptop. We create a new blocking stub with the managed channel that we have built in the setup function. Then we use a stub to call create laptop with a request object. The server will return a response. We assert that the response is not null, and that the response.id should be equal to the input laptop.id. Finally, we find the ID in the store. Then it should be found or not null. Okay, let's run this test. It passed. Now I will duplicate this test and change it for the second case. This is going to be the case with an empty ID. So here I will convert the laptop to a builder, set ID to an empty string, and rebuild it. Now if we run this test, it failed because we are still expecting the created laptop ID to be equal to the input laptop ID. So let's change this assert command to just check that the response ID is not empty. Now the test passed. The third case is when the client sends an invalid ID. Here I will just change this laptop ID to invalid and assert that the response ID is null. The most important thing is we expect to get a status runtime exception in this case. Alright, let's run the test. It passed. Actually, I think the response might be null too. The test still passed, so it looks like the assert command is not executed after the exception is caught. Now the last case. Client sends an ID that already exists. Here I will generate a normal random laptop and save it to the store before making the request. This case we also expect to get a status runtime exception, so there's nothing more to be changed. Let's run the test. It passed. Now let's run all unit tests together. There are 4 green ticks here, so they all passed. Excellent. And that's the end of this lecture. Now you know how to implement and test the unary RPC in both Golang and Java. In the next lecture, we will learn how to implement the second type of gRPC, which is server streaming. I hope the course is useful for you. Happy coding and see you later.